Okay, students, on this video, I'm going to show you how to do what's called a stress analysis. And the stress analysis could be done on pretty much any parts that you want to check or analyze to make sure that it's able to hold up to the level of stress based on weight. Okay, so the stress analysis, whenever you're working on a part and it's complete, you have whatever holes and fillets and whatever the design looks like. In this case, it's going to be a bracket. And you can maybe kind of imagine the use of this one is just a generic bracket. It's going to be attached to a wall here, and then maybe with a fastener of some sort, and this bolt is going to go through all the way into the wall. And in here, it's going to be holding up to the wall, and then we're going to put some weight on it. What kind of weight, I don't know. It just depends on the application. It could be a bracket to hold up a big industrial shelf of some sort. You just don't know. It just really depends on the application that you want. But I'm going to show you the stress analysis based on that scenario, where this is going to be, once again, attached to a wall. We're going to fasten it here with a bolt or something to the wall, and then we're going to put some weight on here and see if this bracket's going to fail or not. Okay, and it'll tell us if it's going to fail. It's pretty neat how this works. Okay. So I go up here to the stress analysis. I click on this button. So once you have the part done and you're in 3D, when you have the extrude and everything like that, it's where you should see the stress analysis simulation. You click on stress analysis. And by doing that, you notice that the ribbon has changed. Okay, so now it goes over to the analysis tab, and notice I really can't do much of anything until I go and start on the first button, which is create the study. So I need to create a simulation first, so I can then start analyzing this part to see if it's going to work. So I'm going to click on create study. Okay, so then again, notice all the different settings that I would have to adjust. I am not a mechanical engineer, but just to let you know that there are different ways and different things you have to understand. And if you are a mechanical engineer, you would have to go and adjust these things based on your scenario. I'm just going to leave everything default. I'm going to go with just a single point stress, where I'm going to apply stress at a single point. But it looks like you can do different types of objectives. But at this point, I'm just going to leave everything alone and hit OK so I can continue. Okay. So again, you notice the ribbon is different. And what I need to do next is I need to assign the material. So the next thing I need to do is I need to tell it what type of material is this part. So I'm going to click over here where it says assign. And it takes a little while because it needs to go and generate the library. And it's going to ask me what is going to be the material of this bracket. Okay. As far as the original material, when I designed it originally, I never really defined a material. So I'm going to leave the original material alone. You can do that when you're doing the part file, but in this case, I didn't do it, but I could. Within the part file, I can generate the material. So I'm just going to override it for this analysis. I'm going to click here on material override, and I'm just going to pick the type of material this happens to be. So you do need to know what type of material it is. It could be copper, gold, if you wanted to analyze this, if it was a piece of gold or plastic or lead. So it really, again, just depends on the type of material that you're looking at. So in this case, I'm just going to go with, you can even go with titanium. That's pretty cool. I'm just going to go with steel. I'm just going to call it, I guess we'll go with mild steel. Okay. And what is this doing? It's basically taking the physical properties, in this case, of mild steel, depending on how the strength of the steel, and you can probably think of the fact that steel is obviously a lot stronger than rubber or just a silicone type of thing. So, it really just depends on the type of application. Okay, so it does take those physical properties and hit OK. Okay. All right, so I assigned the material. And then the next thing I need to do is I need to adjust. It's kind of like going down the list right in here. I need to go and define the constraints. So as far as the constraints, that's where I need to then theoretically attach it to the wall. Like it's going to be attached to the wall. I mentioned that I'm going to put a bolt on here and attach it. So what I'm going to do is I'm going to attach a constraint to the drill hole. It's almost like this surface here is what's going to be constrained and will not have any type of movement. Okay. So let me see. Again, I don't do this every day. So let me just kind of remember how I do this. I think it's under fixed constraint. I pick the location, and I'm going to pick the cylinder. It's just, again, like if you're putting a bolt on that across the cylinder into a wall, and then I'm going to hit OK. All right. So that's our first constraint. Is going to be this cylinder. That's where it's being attached to the wall, theoretically speaking. Okay. Then I need to apply a load. So now is where I can start putting weight on this thing. So, it is a scientific thing. So I'm going to go click on load. I'm going to go with a force load. You can kind of see how I'm going to be doing that. I'm just going to apply pressure to it. So I'm going to click force. Location is going to be, I'm going to use this face. Okay. That's not really what I wanted to do. So let me cancel that, because I wanted to apply the load. And I probably should have drawn like a drill hole or something here, because I need to apply the load this way. So I need to apply the load that way to analyze this thing. Okay. So I'm going to cancel that. I guess I picked the wrong option. I did mention I don't do this every day. So I'm going to press on force again. And I guess I'm going to put it on this surface here. And on that surface is where I'm going to apply the load. And then it asks me, or actually I can even do this. I think I can place it on this edge. So let's say I'm going to apply the force on this edge. And this is part of the analysis. It really depends on how you're trying to do this. And then it's asking me how many pounds of force. Okay. How about if we put 1,000 pounds? Half a ton of force on that thing. Okay. So it's been constrained. I defined the material as mild steel, and I'm applying a 1,000 pound force on this bracket. All right. Okay. So there's our force. And I think that should be it. But I guess we're going to find out. Okay. So I played the force. And let's see if we can go ahead and simulate it and solve it. All right. So I was getting ready to run the study. Once again, I did need to find the material, the constraints, and the loads, and run it. Okay. So by doing that, notice that what this thing did, it's pretty much telling me it does work. It does work. Okay. And you can kind of see how much it's going to flex. So this thing is actually analyzing the material. It's analyzing where it's constraining right in here. You can kind of see the red. The red is where it's getting a lot of the pressure. So when we're applying 1,000 pounds of force here, you can kind of see where this is where it's getting a little bit more critical, but it's actually not too bad. Okay, it's actually not too bad. Okay. So then the other thing I can do is I can actually animate it. So I can kind of look at this thing and see that, okay, that's going to work. I can maybe apply more force to it. I can go back over here to my loads, and I can go in here and right click and edit the force load and maybe change it to 5,000 pounds. Let's try that. And then simulate that one and see if it's able to withhold 5,000 pounds. Okay. It's going to fail. So in this case, the deformation is large. So 5,000 pounds is too much for this bracket. So I tried it and it didn't work. Okay. So then the design will not work for a 5,000 pound load. So that's how you start analyzing this thing. Go over here and, okay, well, it's too much. So then maybe it's only meant to be for 3,000 pounds. Let's give that a shot. Simulate that one. Run the study. And sure enough, even 3,000 is too much. So again, you can kind of see how you're starting to design a bracket depending on the use. Okay. If this doesn't work, what could I do? Could I just simply go back and change the material and say, okay, steel is not going to work for me. Maybe what I need to do is I need to go to a different type of material. Maybe I can go to titanium. But then how much does titanium cost versus steel? So that's the design process, ladies and gentlemen. That is true mechanical engineering. You figure out the function, you figure out what the purpose of that machine part is, what does it do, why, and then you start analyzing to make sure it's going to work. So maybe right now it's not working at 3,000 pounds. So maybe what I can do is I can finish the analysis, and maybe I can just adjust the design. Maybe I can add a fillet in here. I can go over here and add a fillet. Let's see if that's going to make a difference. It should. I can tell you that much right now, because fillets are actually structural. Okay, so it's kind of weird that fillets, look nice. They make everything round, but it's actually part of the structure. It's part of the structure. So I can go back to the stress analysis. Now that I have the fillet in here, I think I left it with a 3,000 pound load. Oh, sorry. Force 1. Edit the first load as a 3,000 pounds, and then simulate that one. It failed right now, but maybe that fillet would help it. I don't know. It did not. It did not. Okay. So I can kind of look at see where it's critical. So really the whole thing isn't critical as much. It's just that this is just, it's not working here. So then maybe what I can do is I can go to the original sketch, edit that sketch, and make it a little bit thicker. 0.25 is too little. Let's go with maybe 0.35 and make that a little bit thicker. So that, once again, ladies and gentlemen, is exactly how mechanical engineering works. So you start designing and checking and adjusting maybe materials. And let's see if now, by making this thicker, will it be able to hold a 3,000 pound load? No, still not. So I'm going to stop there because, again, it's just the design process is how this works. Okay? I did want to show you how to animate it, but I'm going to change the load back. I'm just going to change it back to 1,000 pounds, but I just wanted to show you a little bit of that process and the mechanical engineering process. Run. So the 1,000 pounds does work. Okay. So then what I can do is I can go over here to animate, and then under animate, what I can do is I can just play, and it'll show me a small animation of the process, and it'll show you at what point it starts getting more critical. You can kind of see right in here. You can zoom in here and see how it's starting to get critical more and more as it's applying the pressure. Okay. And you can mess around with this video. You can go over here, and instead of doing it in 10 steps, I can do it maybe in 30 steps. And then instead of normal, you can maybe go faster and then start making a little animation. Of course, I did it in 30 steps. So maybe go fastest. Of course, 30 steps takes 30 steps to go through that process. Maybe I'll do it in 10 steps. It's a little bit faster. Okay. And finally, you can actually make a video out of this thing. You can make a video out of this thing. You can send it to the client, tell them, no, the bracket that we designed didn't work. Can I change it? Can I maybe use a different type of material, whatever the case may be? But once again, that's how you do a quick analysis of materials on designs on Inventor.